Okay, so we're going to talk about the fundamental theorem of algebra. So not too much to write down here, but more just understanding what these things are that we're going to talk about. So it says right here, for the fundamental theorem of algebra, if f of x is an nth degree polynomial, where n is greater than 0, then f has at least one 0 in the complex number system. This is the key here. Knowing that we're talking about the complex number system. So we're saying we have f of x, nth degree polynomial, the degree is greater than 0. Then it has to have at least one 0 that it could be real, right? Because real numbers are in the complex number system. It could be imaginary, right? That's also in the complex number system, and so on. So just something for us to think about there, which honestly, it's pretty trivial. We already know that. Then the other one to talk about is the linear factorization theorem. We actually done an example recently related to this. It says if f of x is a polynomial of degree n, where n is greater than 0, then f has precisely n linear factors. Or in other words, whatever the degree is, that's how many linear factors we would have, which again makes sense to us. Nothing too crazy. Notice here that we have a sub n. We've talked about how if we have different roots or factors, that we could come up with an infinite amount of equations that have those same factors or roots. We would just be changing that leading coefficient. So that's what that a sub n is here. Okay, so just talked about the fundamental theorem of algebra, pretty trivial to us, and we just know that every nth degree polynomial will have exactly n zeros.